Now, looking at our node class, we're not going to use much. We're not going to get any values that are nodes or anything. So in like previous lab, we use getters and setter. We're not going to be really interacting with this node class at all. So what we can do is make a private int data. We are going to make a private node next, and these will basically store the data and the next value. And then we're going to make a constructor so that we can access them, and our constructor is going to be public. We're going to do public node, and then we're going to have inside of here just the data, because all we want to do is add to our nodes into our list of nodes. So this is kind of like a list node. We have data, then we have the next value, the next value, and the next value, and we just want to access the data value itself. So we're just going to have in here this dot data is equal to data. And so that's it for our node class. We can now look at the queue class, which is going to use the node class. So inside of here, we are going to need to make a head and tail value. And the reason why we need to make a head and tail value is because we need to be able to add and remove things from our queue. When we add things to our queue, we add it to the tail. When we remove things, we remove it from the head, unless special cases where the list is like empty or we only have one value. So starting off in here, all we need is to see if our queue is empty, because we're going to use that in the Radix. And then we also need to see if we can, or we need to code an enqueue and dequeue, which is basically an add and remove method. These aren't going to be static because we're going to make an instance of this class in our Radix class. So we won't have any static modifiers here in the functions. So we have this class queue. We're starting out. We're going to have a node head, and then we're also going to have a private, I'm going to see if I can do this all in one line, tail. Let's see if that works. It does work. So we have a private node head and private node tail. We want to check if it's empty or not, so we need a boolean method for it. We're going to do public boolean is empty, and then inside of here we will check if it's empty or not. And so we're just going to return if head is equal to null. And if head is equal to null, that means our list is empty, and so we would return true. It is empty. Otherwise we would return false. So just commenting this, we are just returning if head is empty. Now we can work on our add or enqueue method. So we're going to come down here. We are going to do a public void, and we'll just call this enqueue. And then we're going to pass in some data value because this is the value that we want to add. Now inside of here, there are a couple of different cases that we can look at. So the first case that we can look at is if we have an empty head, if our list is empty. Before we do that though, we should create a new node. So creating our new node, we're going to say node is equal to, or we're going to call it node, and we'll set this equal to a new node. And this is basically making an instance of this node class so we're able to use it. We do need to pass in a value because we have this public constructor right here that's asking for a value. We don't have an empty one or a general one. So we're going to just pass in data, and this is this data right here. We're adding it to the node. So we can say, well, if the head is empty, we will point head to tail. So if our head is empty, we're going to say that head is equal to null, and we're going to say that head is equal to the node since it's being the only thing added in there. And then we also have to set tail equal to node. So we will do if head is equal to null, then we're going to come down here and we're going to say, well, our head must equal the new node. And then also that our tail has to equal the node. We're going to be in an else statement, an else if statement. We're going to say if the tail is not empty, meaning that our list is not empty, because, well, if we have one thing in our list, like right here, we have one thing in our list, then the head and tail point to something. That means our tail is not empty. So if tail is not empty, the value after the current tail is, we'll say, our new node. And so we can come down here and we can say else if our tail does not equal null. We're going to be inside of here, and then we're just going to say, well, our tail dot next, the next value in here has to equal to our node we're passing in. And then also, oh, it seems like we can't make the next value private. Otherwise, we would need like a getter to get this. But we can just make it public. We won't write out a getter. So we'll just have a public node next instead of a private. So we have this else if inside of here. And well, we also need to set the tail equal to node. Well, since both of these require that the tail be set to node, what we can do is just take it out of here and we can write it down here and say that tail is equal to node. Since whichever one of these happen, the tail is going to have to equal to node. Now what we can do is we can actually write out some commentation for this. So we can say this adds to our queue. And so we are basically in-queuing something. We're adding it to our queue. And then we have our parameter, and this data is being added to the queue. And now that that's done, we can come down below it, and we are going to write our dequeue, which is basically the remove method. So in here, we have public void dequeue, and we aren't going to be passing anything in. We're just going to be calling this to remove something. So in our dequeue, I'll leave it right here, we are going to return the data since it now stores the head. Remember, dequeue, it returns data, it returns whatever the head is, and then it sets the head to the next value. So what we're going to have to do is say that our int data, this is what we're returning, and this should be an int instead of a void because we are returning something. We are going to be, in fact, returning data. So we're going to say int data is equal to head dot data. And this will give us the data value at our head. And just like our node, this has to be public or we have to have a getter for it. So instead of making a getter, we'll just make this a public instead. So all of this is public, no privates in here. And so we have a return data that we can do. Before we return the data though, we got to make our previous next value be the new head. What happened to the recording, but looking back at this, we made this dequeue. Actually, we should be at the dequeue, and basically we are returning the data since it is now stored in the head. We want to dequeue something, so that's removing it from the front and returning it. So we're returning this int data. We set data equal to head.queue or head.data. We're returning the data here, and then we're setting the new head to the next value. So head is equal to head.next. This gets the next. And then if our tail node, which is the next value, which is now the head, is null, then, well, we have to say if head is equal to null, that means our tail is null. Because if head has nothing in it, our tail has nothing in it. So we have to rearrange the tail pointer.